So coming to the next part of kinematics, that is projectile motion. So now defining that, so it is a common type of curvilinear motion. So projectile motion, it is a type of curvilinear motion. So when a particle or any object is thrown at an angle alpha, is thrown at an angle with respect to the horizontal, so it follows a parabolic path. Following this parabolic path is known as projectile motion. Yeah. Now what we'll do, we'll take a case wherein, so there is a particle at the ground surface and which is thrown, which is thrown at an inclination alpha with respect to the horizontal ground surface, which is thrown with an inclination of alpha with respect to the horizontal ground surface. So then it follows a parabolic path like this. It follows a parabolic path. Now this motion itself we call it as what? Projectile motion. I'm quickly briefing that what it says, projectile motion. So it is a type of curvilinear motion. So when a particle or any object or any body is thrown at some inclination, where your inclination should not be 90 degree. Your inclination should not be 90 degree. If it is 90 degree, again it will be a rectilinear motion. It goes up and it will come back in the same direction, and that will become a rectilinear motion. So but whatever a particle is thrown at, the inclination has to be not equal to 90 degree. It has to be less than or greater than 90 degree. In that case, it follows this the parabolic path. It follows this parabolic path, and this parabolic path itself, the motion of the body along this parabolic path itself, we call it as what? Projectile motion. Like discussed earlier, so now when particle is following this parabolic path or during this projectile motion, you can see that your particle is changing both along x direction as well as along y direction. It is changing its position along x direction as well as along y direction. So when it is moving along x direction, it is not coming across any of the resistance or any of the change in velocity. I'll repeat. Like discussed earlier, so during particle while following this projectile motion, so will be changing its position along x direction as well as along y direction. Now while changing its position along x direction, it will not come across any resistance or any change in velocity along x direction. Now whatever is the initial velocity, say it has some initial velocity u, it is thrown with some initial velocity u and inclination alpha with respect to the x axis. So it will have two components. One is ux and other one is uy. So it will have two components. One is ux, so that is component of initial velocity along x direction and component of initial velocity along y direction. Now for the projectile motion, whatever is the initial velocity, that is ux along x direction, it will continue to move with the same velocity until it reaches the final point. So it means the final velocity along x direction also will be ux. The final velocity along x direction will be us. Now why your initial velocity and final velocity along x direction will be same? Because so it does not come across any resistance along x direction. It does not come across any resistance unless there is any wind in opposite direction or in the same direction. If there is no wind disturbance, your initial velocity along x direction and initial velocity along x direction and final velocity along x direction will remain same. When your velocities are same along x direction, your acceleration along x direction becomes 0. Now but whereas in y direction, now before going to this part, already you have seen in the last few classes, motion under gravity, any particle thrown vertically upward continues to move in straight and reaches some peak value, will be in a state of rest, then comes back. So why is this happening? Because whenever it is moving along vertical direction, this will be under gravity. This will be exerted by gravity. Now that is why this parabolic path will be followed. Now say the y component of this velocity will be uy. The y component of this velocity, initial velocity will be uy. So now it continues to move with initial velocity uy, then reaches a peak value somewhere at the center, you can call it as, reaches a peak value, then it starts returning to the ground. then it starts returning to the ground. So it means your velocity along y direction will be varying. Your velocity along y direction will be varying. That is mainly because of acceleration exerted by the ground surface. Acceleration exerted by the ground surface. Now that is why along y direction it is subjected to acceleration of 9.81 meter per second square. Now hope this projectile motion is clear. Now we are taking a very elementary case. Now we'll be we'll be writing the expressions directly. Many of the times they'll not be asking is what is that expression in your exams. You have to remember this expression, and whatever problems asked you should be able to solve. Now we'll be writing equations of projectile motion. For this case you have to be very much careful. For horizontal ground surface we are taking a very ideal case. What is that? These equations whatever we have written for ideal case of when ground surface is horizontal. When ground surface is horizontal. So now one by one, y. Now you, what is that? You take, this is the origin where the particle is thrown at. So once the particle is thrown at with some initial velocity, you can see that. So for every x ordinate, your particle has moved a vertical distance of y, which we call it as y ordinate. Now when it is thrown from the origin, so it goes on changing the position in x direction as well as y direction. In x direction, your position of the particle when thrown will be changing its position along x direction as well as in y direction. So now if you want to calculate the y ordinate from the horizontal ground surface, say at a distance of x, so we can use this formula. Now what is this formula is helping us to calculate? The y ordinate or change in position of the particle along y direction from the horizontal ground surface measured at whatever x ordinate from the origin. Now it says what? Y is equal to, so what is y? It is the position of the particle. It is the position of the particle from the horizontal ground surface at a particular distance x from the origin. Now say first we'll go through the expression. Y is equal to x tan alpha minus g into x square divided by 2 u square cos square alpha. Now quickly briefing the terms here. So alpha is what? The inclination at which the particle is thrown. Inclination with respect to the horizontal ground surface at which the particle is thrown. Alpha. X I'll come back. G is acceleration due to gravity, which is 9.81. X I'll come back. U is the initial velocity will be given to you, and alpha is again the inclination. Now what is the term we have to understand? X. So X is the change in position of the particle at along x direction. X is change in position of the particle along x direction. Now say I want the y change in position along y direction at an interval of say 10 meter from the origin along x direction. So here I will be substituting what? 10. Now say if I want it at 20 meter along x direction. Now from origin at 20 meter, if I want to know what is the y ordinate, so I will be substituting x as 20 meters here. I will be substituting x as 20 meters. Now hope this equation is clear. So next is what? R, that is the range, which we define it as range. Now what is range? It is horizontal distance covered during the flight. Now flight is nothing but what? The projectile motion followed. Flight is nothing but the projectile motion followed. Now whatever the horizontal distance covered, so now once the particle is thrown from the origin, so it follows this path and reaches the final point. Now whatever the horizontal distance now of this horizontal projected distance of this parabolic path itself, we call it as what? Range. Now you can see here this distance is the horizontal distance covered by the particle, or x distance covered by the particle during its entire flight, and which we represented by r, and we call it as range. And that is defined as u square sine 2 alpha divided by g. Now again u stands for initial velocity and alpha stands for inclination at which the particle is thrown with respect to the horizontal ground. Alpha represents an inclination with which the particle is thrown with respect to the horizontal ground, and again g is the acceleration due to gravity. So next is what? Time of flight. So I have not written in detail time of flight, that is t. So it is the total time taken by the particle from initial point to the final point during the entire flight. What is time of flight or denoted by t? It is total time taken by the particle from the initial point to the final point during its entire flight. So that is calculated as how? 2u sine alpha divided by g. Again, u being the initial velocity, alpha inclination, and g is acceleration due to gravity. Yeah. Next, the next entity is h. So h is nothing but what? Maximum height reached by the particle from the horizontal ground during the flight. Now earlier also we have seen when particle was thrown vertically upward, so what is that? It was reaching some peak height, then it was returning. Now here also, when it is thrown with some inclination, reaches some peak height somewhere exactly in the middle. So it reaches the peak height, so it continues to move vertically up and reaches the peak height. Once after reaching the peak height, then it starts returning to the ground. Now that happens exactly at the center of the horizontal range. Clear? And that height it is denoted by h, and that is calculated as u square sine square alpha divided by 2g. Now this has to be clear. This has to be u square sine square alpha divided by 2g. U square sine square alpha divided by 2g. Now hope these expressions are clear. So I'll read the problem. A gun fires a bullet from the ground. At velocity of 100 meter per second. Initial velocity of 100 meter per second, making 60 degree with respect to the horizontal ground. Now calculate r, that is horizontal range, time of flight, and the maximum height or the peak height reached during the flight. Now try doing that. We already have these expressions. So all you have to do is, before that you can write down what are the given data. So initial velocity is how much? 100 meter per seconds, and alpha it says 60 degree. Alpha is 60 degree. Yeah. So you are asked to calculate what now? R, that is horizontal range. Now t, it is time of flight, and h, that is maximum height or the peak height reached during the flight. Now quickly you can first start doing r. I'll do that. Yeah. Now first we can start with r. So writing down the expression for r. R says what? U square sine 2 alpha divided by g. So now, u is 100 square into sine 2 alpha. So alpha is 60. So you can write 2 into 60 whole divided by 9.81. So with that, quickly get me the answer r. See, one more thing you have to be careful. So all units have to be, all your entities have to be in the same units. So velocity is meter per second again, and acceleration, that is also meter per second square. So sometimes your velocity may be given in terms of kilometer per hour or something like that. So while substituting back, see to it that all are in the same units. 82.79 meters. So this distance will be how much? 882.79 meters. 882.79 meters. Yeah. Now R we have calculated. So next we have to calculate is what? T. R is done. Next we have to calculate is what? Time of flight. Now whatever is times taken by the particle from initial point to the final point. For that you have to use 2u sine alpha by g. 2. So directly I will substitute. Now u is again 100 into sine 60 degree divided by 9.81. 2u sine alpha by g. T is how much? 17.65. 17.656 seconds. 17.65. So next h. So h is the peak height or the maximum height reached during the flight. H, the 382.25 should be the correct answer. Okay. So now small addition to the problem we'll do. Yeah. So this is all calculated. So let me call this as 1 and second calculate. Yeah. Now second part says, so what it says, there is a wall of height 280 meters at a horizontal distance of 600 meter from the origin. So from the origin at a distance of 600 meter, from the origin at a distance of how much? So I'll write here. At a distance, horizontal distance of 600 meter. So there is a wall of height 280 meters. So now we have to check whether this bullet passes the wall or it will be hitting the wall. So it is nothing but what you have to calculate what is the y ordinate. It is nothing but you have to calculate what is the y ordinate at a distance of y ordinate of the bullet at a distance of x is equal to 600 from the origin. So for that you have to use this expression. To calculate this y ordinate, we have to use this expression. Now this expression says what? X tan alpha minus gx square by 2 u square cos square alpha. Now what is x will be here? So it is at a distance of 600 meter. Now try doing that now. Y is equal to x is 600 in tan 60 minus g is 9.81 into 600 square whole divided by 2 into 100 square into that is cos 60 whole square. Cos 60 whole square. Get this value of y now. Y is equal to 332.91 meter. So now you tell me. See, the y ordinate is from the ground. So this is, so the y ordinate of the bullet is 332.91 from at a distance of 600 from the origin, and the wall height is 280 meter. Wall height is 280 meter. Now you have to tell me whether the bullet surpasses the wall or it will be hitting the wall. See, what is that? The ordinate, y ordinate of the bullet is 332.91, whereas the height of the wall is how much? 280 meter. Height of the wall is 280 meter. So definitely the bullet will cross the wall. Definitely the bullet will cross the wall. So what if this is 350? What if this is not 280? What if this is 350 meter? What if the height of the wall is, instead of 280, what if it is 350 meter at same location? Yeah, it will hit the wall. So because the ordinate of the bullet will be 332 and height of the wall is 350, it will not be able to surpass or it hit the wall. See, you might come across these kind of problems.